Hi, my name is Chin Lee. I'm the CEO, CTO of Lewis Communications. I'm going to talk to you about a highly integrated eFPGA SoC processor. You are in luck because this is my first ever YouTube video. So hopefully I'll be doing okay. On the block diagram, you see on the left hand side, that is the analog portion of the device. It has 16 channels of A to D converter and 16 channels of D to A converters. We like that to be at about 6 gig of sample per second or higher. Okay, and in the blue portion of the diagram, you see the eFPGA. eFPGA is very flexible. It allows you to implement your own algorithms or software-defined radio or DSP or protocol type of processing in there. So it's application-specific processing. Below that, you see the embedded DRAM. Embedded DRAM is on-chip memory and it can be used for storing instructional data memory and buffers. Okay, with memory on the device, it offer you higher security. In the middle of the block diagram, you see the encryption accelerator and the RISC-V CPUs. These are multi-processor scalability for accelerated and security processing. On the left-hand side of the block diagram, you see many peripherals, and this is where the high integration come in. So you see the LPDDR3, DDR4 controller that has ability to control external memory with trust zone capability, and the flash memory controller for control external flash memories. PCI Express controller interface allow you to interface to the host type of functions, and below that you see the 10 gig, 1 gig high-speed Ethernet. Those modules has ability to do 1 gig, 2.5 gig or 5 gig as well. And the serial controllers on the bottom of the block diagram, it can do UART, I2C, USB, so very flexible serial communication. The PCI Express controller can be by 8 type of PCI Express or by 4, and it can support Gen 2 or Gen 3 type of PCI Express. So we purposely integrate a lot of function into this device and offer high performance as well as security and make it very flexible. So in addition to those functions, we also include Trojan protections in the fabric of the device. And RISC-V support hypervisor concept like SEL4, for example. And of course, we will have capability for debug and programming support. The target market, the device is very flexible, so it's intended to support a wide range of applications from small to large devices for air, ground, sea vehicles, or robots. In communication, it can support applications like satellite communication, millimeter wave. In millimeter wave, beamforming or multi-transport type of capability offer anti-jam, LPI, LPD capability, and it can even support ad hoc networking or handheld type of device or Wi-Fi base station types of applications. And the device is very suitable for sensors. All its modules or I/O can be turned off, so when it's not in use. So it's a power saving. It supports many embedded applications. For example, motor control, avionics, or in-vehicle type of control or networking functions. I put a few diagrams of the typical devices that you see in military type of application. So at the bottom left, you see the soldiers. So on a soldier, they can carry backpack type of electronics or handheld type electronics, and this device is suitable for that. And in ground vehicles, as I mentioned before, it has many applications in there, from control to communication type of things. Or in helicopters or drones, a global HOTS or satellite type of communications system, there are many applications that can use these chips, or even communication system at the base, for example. History has shown that a very useful device, a very flexible, useful device, has long-term longevity, and it can generate cost-effective in the long run with economy of scale. Okay. There are several improvements we put into this device, but our intent is to do a single design, single qualification process for military, but from that single design we can generate a family of SoC products out of it, and it's a cost saving for a long term. It's designed to be flexible, so it's total programmability, and so different firmware type can be loaded into a system for different applications. So a system can be shared or be used for different missions. So it's a cost saving. High performance function can be embedded into the eFPGA and with on-chip memory that give you very high performance. Multi-level securities are built into this device. At the system level, it supports hypervisor concept, and it has hardware Trojan protections. The RISC-V CPU has been security enhanced by DARPA, for example, okay, and it's designed specifically for DoD type applications. And it also have encryption capability, error correction, trust zone support. There are several modules on the device, so it offers a very high level of integrations. High level integration means less chip for the system, better size, better weight, better power, and low in cost, and less in maintenance. Our team is Oasis Communications. We have a very deep background in PowerPC, SoC, network processor type of architectures. We have done front end as well as back end. We've done chips that the entire process, and we have done chips that contain analog as well as custom memory design on the device. And we developed FPGA for many years, over 19 years of experience in FPGA, and our company is one of approximately 20 entities selected by DARPA for electronics EAI program. We have a few previous partners, and with Tier 1 defense contractor, we have received letter of support from them for satellite communication. They will help defining architecture as well as help testing on military vehicles. We also have university partners for satellite communications or millimeter wave type applications. But we really would like to get a lot of contribution from you. We are very open to your suggestions. You can contribute in the front end, the back end, or product engineering areas. You can pick a module or a section of the chip and design it and develop it, and we can integrate it, and you can keep the IP yourself. So if you have even if you're a one-person company or a 1,000-person company, we welcome your contributions. Anything from synthesis to PHY to analog to e-memory to configure I/O or DFT, informal verification, or security enhancement. Or you can develop full applications with our device and offer different algorithms and things that you can use to sell and support the customers. I look forward to hearing from you, and I give you my email address here, janelle@luis.com. And I thank you for your time.